In June of 1974, Richard Feynman stepped up to a podium at the California Institute of Technology. In front of him sat the graduating class, dressed in academic robes, surrounded by proud families and faculty. These students had survived one of the most demanding science educations in the United States. They expected encouragement, inspiration, perhaps a reminder that they were about to help shape the future of human knowledge. That is not what they received. Instead, Feynman delivered a message that unsettled nearly everyone in the audience. He told them that much of what passed for science, including work published in respected journals, taught in universities, and funded by major institutions, was deeply flawed. Worse than flawed, he said much of it was meaningless. It looked like science. It sounded like science. But it lacked the one thing that actually mattered. He called it cargo cult science. This was not an offhand remark or a moment of rhetorical excess. The speech was carefully constructed and deeply serious. It was later published under the same title and preserved in Caltech's archives. Over time, it became one of Feynman's most frequently cited warnings about how scientific thinking can decay while still wearing the outward appearance of rigor. To explain what he meant, Feynman took the audience far away from California, back to the islands of the South Pacific during World War II. During the war, Allied forces established air bases on remote islands scattered across the Pacific Ocean. These islands had little prior contact with modern industrial societies. Suddenly, massive cargo planes began arriving from the sky. They landed on newly built runways and unloaded extraordinary supplies: food, tools, medicine, clothing, machines. To the islanders, this seemed miraculous. They watched closely. Soldiers sat in tall towers wearing headsets, speaking into strange devices. Other men stood along the runways, waving paddles in precise patterns. Antennas rose into the air. Certain rituals were always performed, and then, reliably, the planes appeared. To the observers, the connection seemed obvious. These actions caused the planes to come. Then the war ended. The soldiers departed. The airfields were abandoned. The planes stopped arriving. The flow of goods disappeared. Faced with this loss, the islanders did what seemed entirely reasonable. They tried to recreate the conditions that had brought the planes before. They cleared long strips of land to serve as runways. They built control towers from bamboo and wood. They carved imitation headphones from coconut shells and wore them while sitting in the towers. They constructed antenna-like structures from straw and vines. Men stood along the runways, waving palm fronds in the same patterns they had seen during the war. Every visible detail was copied with astonishing care. The form was nearly perfect, but no planes came. The reason, of course, was simple. The islanders had reproduced the appearance of the process without understanding the underlying mechanisms. They did not have radar, radio communication, global logistics networks, aircraft manufacturing, or trained pilots. They had replicated the rituals, not the causes. This, Feynman told the graduates, was exactly what much of modern science had become. Cargo cult science is research that follows the external forms of scientific work, experiments, measurements, graphs, statistical analysis, but lacks the internal discipline that gives science its power. It looks legitimate. It uses technical language. It may even produce numbers, but it does not genuinely test ideas against reality. The core problem, Feynman argued, is not dishonesty in the usual sense. Most people practicing cargo cult science are sincere. They believe they are doing real research. The failure lies deeper. It is a failure to actively try to prove oneself wrong. True science, in Feynman's view, requires an almost uncomfortable level of intellectual honesty. A scientist must bend over backward to expose weaknesses in their own work. They must report not only the results that support their hypothesis, but also the ones that don't. They must acknowledge alternative explanations. They must design experiments that could actually falsify their ideas, not just confirm them. Cargo cult science does the opposite. It arranges experiments so that success is almost guaranteed. It explains away inconvenient data. It adjusts definitions after the fact. It relies on statistical tricks, selective reporting, and vague conclusions. The rituals are performed, but the planes never arrive. Feynman warned the graduates that even with elite training, they were not immune. In fact, they were especially vulnerable. Years of coursework teach students how to solve problems, apply formulas, and follow established methods, but very little time is spent teaching how to doubt results, how to recognize hidden assumptions, or how to question whether an experiment actually measures what it claims to measure. He emphasized that the corruption of scientific thinking does not require bad intentions. It only requires comfort. Once a field becomes established, its methods harden into tradition. Papers cite earlier papers. Experiments are designed to align with accepted theories. Funding rewards safe, incremental results. Over time, entire disciplines can drift away from reality while still appearing productive. The danger is greatest when results are difficult to test independently. Fields that rely on complex statistics, poorly defined variables, or long chains of inference are especially susceptible. In such cases, it becomes easy to confuse agreement within a community for agreement with nature. Feynman was not rejecting science, he was defending it. He believed that the strength of science came not from authority, consensus, or sophistication, but from a specific attitude, relentless skepticism combined with respect for evidence. Nature, he reminded them, cannot be fooled. You can fool yourself, you can fool others, but reality will not cooperate with false ideas, no matter how carefully dressed they are. The cargo cult metaphor was devastating precisely because it was so accurate. The islanders were not foolish. They were observant and logical within the limits of their information. Likewise, many scientists are intelligent, hard-working, and well-trained, but without a deep commitment to testing assumptions and exposing failure, intelligence alone is not enough. Feynman ended with a challenge. The responsibility of a scientist, he said, is not just to follow procedures, but to maintain integrity at every step. That means resisting the temptation to publish prematurely, to overstate conclusions, or to ignore contradictions. It means valuing truth over reputation and understanding over success. The lesson of cargo cult science is uncomfortable because it has no clear endpoint. There is no certification that guarantees immunity. The risk never disappears. Every generation of scientists must actively guard against replacing understanding with ritual. That is why the speech still matters. It is not a critique of the past, but a warning for the future. As long as science exists, the temptation to imitate its outward form without preserving its inner discipline will remain. The planes only land when the underlying structure is real. The planes never came. They had everything that looked like an airstrip, everything that appeared to be the conditions for cargo planes to land. But they were missing something fundamental, something invisible. They didn't understand radio waves or flight mechanics or military supply chains. They had copied the form without understanding the substance. To an outside observer, it looked exactly like an airport. To the planes that never came, it was meaningless. Feynman stood at that podium and told those graduating students they were doing the same thing. He wasn't talking about obvious pseudoscience or fringe conspiracy theories. He was talking about published research in academic journals, studies conducted by credentialed scientists at legitimate institutions, work that followed all the apparent rules of scientific methodology, papers that got cited in textbooks. And yet, Feynman argued, most of it shared the same fundamental flaw as those bamboo headphones. It looked like science without being science. Consider one of his examples. For years, researchers studied whether rats could learn to navigate mazes faster with each subsequent attempt. Hundreds of experiments were conducted. Papers were published. Debates raged in psychology journals. Different research groups claimed different results. Some found dramatic learning effects. Music, others found none. The field churned out study after study, each following proper experimental protocols, each with control groups and statistical analysis. Everything appeared rigorous, but Feynman noticed something. When a researcher finally conducted an experiment accounting for whether the rats could actually hear or smell their way through the maze, not just see the visual cues everyone had been measuring, music, the learning effects vanished. For decades, researchers had been inadvertently allowing rats to use sensory information no one was controlling for. Every previous experiment, despite following the form of good science, had music missed this fundamental variable. The papers weren't fraudulent. The researchers weren't stupid. They had the appearance of scientific rigor, but they lacked what Feynman called scientific integrity. This reveals something crucial about the difference between methodology and integrity. Music, you can follow every rule, cite every source, use every statistical tool correctly, and still produce garbage if you're not honestly trying to disprove yourself. The cargo cult scientist runs the experiment. The real scientist tries to think of every reason the experiment might be fooling them. Feynman gave another example that hit closer to home for physicists. Robert Millikan's famous oil drop experiment measured the charge of an electron. Fundamental work that won him the Nobel Prize in 1923. Millikan reported his value with high confidence. His published data showed beautiful consistency. But here's what Feynman discovered when he dug into the history. Millikan's first published value was slightly off. As subsequent physicists tried to replicate his work, they kept getting values slightly different from Millikan's. Each researcher would get a number, compare it to Millikan's prestigious result, assume their own methodology must be flawed, adjust their procedure, and eventually publish a value closer to Millikan's. The next researcher would do the same. For years, the scientific community slowly crept toward the correct value through this chain of partial self-deception. Each physicist thought they were being rigorous. Each followed proper experimental protocols. Each had good reasons to trust Millikan's earlier work, but collectively they were practicing cargo cult science. They had the form of verification without the substance of genuine independent testing. They were unconsciously tuning their results to match expectations rather than measuring reality cleanly. Feynman emphasized this wasn't about dishonesty. Most cargo cult scientists are sincere. They believe they're doing real science. The problem runs deeper than fraud. It's about a type of self-deception so subtle you don't notice you're doing it. Music. He described it this way. The first principle is that you must not fool yourself, and you are the easiest person to fool. That sentence from the 1974 address cuts to the heart of cargo cult thinking. Your own brain actively works against you, seeing your mistakes. You notice evidence that confirms what you believe. You unconsciously discount evidence that contradicts it. You run the experiment until you get the result that seems reasonable, then stop. You interpret ambiguous music data in the direction you expect, and every step feels like you're being objective. This wasn't just about scientific research, but about any field where intellectual honesty matters. Cargo cult thinking appears everywhere. In business, in education, in journalism, in policy, in your own work. Whenever you're going through the motions of rigor without the substance of genuine truth-seeking, you're building a bamboo control tower. Back to that commencement address, Feynman told those graduates about scientific integrity, which he defined as bending over backwards to show how you might be wrong. Not just following the rules, not just being thorough, but actively searching for the ways your own conclusion could be mistaken. He said scientists should give all the information that could call their results into question, not hide contrary evidence in footnotes, not emphasize data that supports their hypothesis while downplaying contradictions. Put the ammunition for your critics right in the abstract. Music. He gave a specific instruction. If you're doing an experiment, you should report everything that you think might make it invalid, not only what you think is right about it. Most researchers do the opposite. They report what supports their conclusion and briefly acknowledge limitations only if forced to. They have reasons. They need publications to get tenure. They need funding. They want their ideas to be taken seriously. Every incentive pushes them toward emphasizing confirmatory evidence and minimizing doubt. The system rewards cargo cult science because cargo cult science produces cleaner narratives, more confident conclusions, and easier to publish papers. Real science is messy. It's full of uncertainties and contradictory data and results that don't make sense. Papers that honestly report all that messiness often look weaker than papers that smooth over the complications. So researchers learn to build bamboo control towers, studies that look rigorous but are actually exercises in selective presentation. But then Feynman went further. He told those graduates that they had a responsibility beyond their own research. They needed to refuse to participate in cargo cult science even when everyone around them accepted it, even when it cost them professionally. He said, "You will not only do no particular good, but if you have any reasons for a feeling of pride on the basis of your accomplishment, you will lose it." That's a devastating message for a commencement speech. You spent 4 years earning this degree, and now you're being told that simply following the norms of your field will make your work worthless and drain your accomplishment of meaning. But Feynman wasn't trying to discourage them. He was warning them about the specific trap that catches people who think they're too educated to fall for obvious nonsense. The cargo cult islanders can be forgiven. They had no framework for understanding radio communication or aerodynamics. They were doing their honest best with limited information. But a physicist who cherry-picks data, a researcher who stops investigating once they get the result they wanted, they music know better. They have the tools to recognize their own self-deception. They just choose to ignore those tools because building a real control tower is harder than building one from bamboo. Consider how this applies today when you're evaluating expertise. Music. Someone has a degree from a prestigious institution. They've published papers in respected journals. They use sophisticated technical language. They present data in compelling visualizations. They cite sources. Every marker of legitimate expertise is present, but are they practicing cargo cult expertise? Are they selectively presenting evidence that supports their preferred narrative while burying contradictions? Are they mistaking the appearance of rigor for actual rigor? Music. The same principle applies today when you're doing your own knowledge work. You research a topic. You find sources that support your existing belief. You organize them into a coherent argument. Music. You anticipate objections and prepare responses. You present your conclusion with confidence. You've done everything that looks like thorough analysis. But did you genuinely try to prove yourself wrong? Did you seek out the strongest counterarguments or music, just the ones you could easily refute? Did you update your belief when you encountered contradictory evidence? Or did you explain away that evidence to preserve your original conclusion? Most people go through life building bamboo control towers without realizing it. Music. They follow career advice that sounds sophisticated, but they never verify whether it actually produces results. They adopt productivity systems that feel rigorous, but never track whether their actual output improves. They learn frameworks and models and methodologies that give them the appearance of expertise without the substance of genuine understanding. They're not being dishonest. They genuinely believe they're being thorough, but they're fooling themselves. Feynman had seen this pattern throughout his career. During the Manhattan Project at Los Alamos, he watched brilliant scientists get so invested in their theoretical models that they ignored experimental data, contradicting their predictions. After the war, he saw academics build entire research programs around fashionable ideas that crumbled when subjected to genuine scrutiny. He noticed how institutions incentivized the appearance of productivity over actual discovery, how funding favored projects that promised clear outcomes over genuine exploration, how peer review rewarded papers that fit expected patterns over papers that challenge assumptions. And he recognized the trap catches everyone eventually, including him. He told a story about his own early research where he'd gotten excited about a result, only to realize later he'd been unconsciously interpreting ambiguous data in the direction he wanted. He hadn't committed fraud, he'd just been human. The experience taught him that intellectual integrity requires constant vigilance against your own motivated reasoning. Music. This brings us to the deepest layer of what Feynman was warning about. Cargo cult science isn't just methodologically flawed research. At its core, science is not a quest for perfect truth. It never was. Science exists for a far more modest and far more demanding purpose, to make us wrong less often, not absolutely right, not certain beyond doubt, just a little less mistaken than we were before. Progress in science is slow, uncomfortable, and often humbling because it requires confronting how easily the human mind deceives itself. Every major scientific practice exists for this reason. Peer review is not about prestige. It is about forcing ideas to survive scrutiny beyond their creator's confidence. Replication exists because individual experiments lie more often than we want to admit. Controlled experiments are designed to isolate causes precisely because intuition is unreliable. Statistical methods exist because humans are exceptionally good at seeing patterns that are not really there. All of these tools serve one purpose: to defend against self-deception. When those practices are followed mechanically without that underlying intent, science loses its soul. The procedures remain, but the meaning disappears. What is left looks impressive from the outside, but is hollow at the center. The rituals are performed, the boxes are checked, the language sounds correct, yet the connection to reality weakens. It is the scientific equivalent of clearing a runway, erecting a tower from bamboo, and waving palm fronds toward the sky while wondering why no aircraft appear. This was the deeper warning Richard Feynman delivered to the Caltech graduates in 1974. He was not accusing scientists of fraud. He was pointing to something more subtle and more dangerous, the gradual replacement of honest inquiry with comfortable routine. Cargo cult science is not built on lies. It is built on misplaced confidence, unexamined assumptions, and the quiet abandonment of doubt. Near the end of his address, Feynman did something unexpected. He did not close with optimism or encouragement. He did not tell the graduates they would change the world. Instead, he warned them that sooner or later they would face a choice. One path would be easy to recognize. It would look like success. They could publish steadily, align with fashionable ideas, secure grants, and gain professional respect. They would attend conferences, cite the right papers, and be seen as productive members of their field. They would rarely face uncomfortable questions because their work would fit neatly into existing frameworks. This path would feel like progress. The other path would be quieter and harder. Practicing real science might mean publishing less often. It might mean challenging accepted assumptions and being labeled difficult. It could mean struggling for funding, defending unpopular conclusions, or watching others advance faster by playing safer games. There would be fewer guarantees of recognition, possibly no guarantees at all. Feynman did not tell them which choice to make. He understood that no one could decide that for them. He simply made clear that the two paths were not the same, even if they looked similar on the surface. To drive the point home, he returned implicitly to the story of the Pacific Islanders. Decades earlier, those communities were still building their makeshift runways. They worked with complete sincerity. They believed deeply that they were doing everything required to bring the cargo back. If someone had told them the truth, that their efforts could never succeed, they would have been devastated. But they had an excuse. They lacked the knowledge to understand the deeper structure behind what they were copying. Modern scientists do not have that excuse. You know the difference between genuinely testing an idea and arranging circumstances so it appears to succeed. You know when you are following evidence wherever it leads versus selecting evidence that supports what you already believe. You know when you are building real understanding and when you are polishing the appearance of expertise. Even when you do not admit it to others, you feel the difference internally. That awareness is what makes cargo cult science ethically serious. It is not ignorance, it is avoidance. Feynman left his audience with an unspoken but unavoidable question. Which runway are you building? Are you constructing something that could actually bring truth down from the sky, even if it takes longer and looks unimpressive? Or are you assembling something that photographs well, earns approval, and sustains the illusion of progress while never connecting to reality? The most dangerous part, Feynman understood, is that the cargo cult version feels productive. There is motion everywhere. Papers are written. Data is analyzed. Meetings are held. Careers advance. The activity itself creates a powerful sense that something meaningful is happening. Because everyone around you is busy too, it reinforces the belief that this must be how science works. But motion is not progress. Activity is not understanding. The planes never arrive, but no one notices because everyone is too focused on maintaining the rituals. The runway is expanded. The control tower is refined. The signals are waved more energetically. And each failure is interpreted not as evidence that something is wrong, but as proof that more effort is required in the same direction. Real science feels different. It is slower, more frustrating, often lonelier. It involves long periods of uncertainty where nothing seems to work. It requires sitting with results that contradict expectations and resisting the urge to explain them away. It demands a willingness to say, I don't know, and to mean it. This is why science is not a collection of facts, but a discipline of humility. It only functions when its practitioners value being less wrong over being admired. The moment reputation, funding, or consensus becomes more important than accuracy, the system begins to drift. Feynman knew that no institution can fully prevent this drift. Rules cannot substitute for integrity. Checklists cannot replace curiosity. There is no external enforcement strong enough to guarantee honesty. In the end, the burden always falls on individuals to decide what kind of work they will do and why. That is why his message still resonates. It was not aimed at one generation or one field. It was aimed at the permanent weakness in human thinking. We want certainty. We want validation. We want our efforts to feel meaningful even when they are not. Science offers no comfort here. It offers only a method, a way of slowly, imperfectly, painfully aligning our beliefs with how the world actually behaves. That method works only when its spirit is preserved, not just its form. The question Feynman left behind still stands, unresolved and personal. Are you trying to understand reality, or are you trying to look like someone who understands reality? One path leads eventually to truth. The other leads to very convincing bamboo runways.